Here in this problem, we have a recently discovered planet, has a mass twice as great as Earth's, but half its radius. What would the approximate size of its gravitational field at the surface of the planet? So the first thing I want to point out is the language here. Twice would imply 2 times, and then half would imply divide by 2. And then gravitational field is just fancy for saying acceleration due to gravity. Okay, so keep the wording here in mind. It says gravitational field, not gravitational force. So field would just imply lowercase g, acceleration due to gravity, which is lowercase g. All right. So the function that you need for this problem is the lowercase g function. The gravitational acceleration is the universal constant times the mass of the planet divided by the radius of the planet. Okay, so whatever the radius of the planet here, I'm just going to call that r. Here's Earth. I'm just going to give you a reference point. Here's Earth on the left side, and then here is planet X on the right side. I'm just going to call this planet whatever this discovered planet is. I don't know what it is. It didn't give me a name, so I'm just going to call it mass X. X for unknown planet. All right, I'm just going to carry this function down. The gravitational acceleration is just going to get applied twice here. I wrote it out for Earth, so g lowercase e, which is equal to capital G times mass of Earth divided by the radius of the Earth squared. Okay, but I'm going to apply the same function again for the mass of planet X here. So the gravitational field for planet X is capital G times the mass of X divided by Rx squared. But as I said earlier, as you practice this problem, make sure you pay attention to the language. Twice implies multiply by 2. Half would suggest you divide by 2. Okay, so here in my work, all I did was I want to substitute out mx. So instead of mx, I want to replace it with the true statement that says 2 times the mass of me, aka twice. And then instead of rx, I'm just going to substitute out rx for half the radius of Earth. So it would be r Earth divided by 2. Use parentheses here, because if you don't use parentheses, you're going to make a common mistake that folks make if they're sloppy with their substitution. Okay, so when you substitute, use parentheses, because what that'll trigger is it'll tell you to distribute this square to re, but also distribute the square to the denominator too. And if you do that properly, the numerator stays the same, except on the bottom now we have re squared, and then we also have a 4, because 2 squared is 4. But you notice here you have a numerator divided by a fraction. So in math, we multiply by the reciprocal of the denominator. So I'm just going to go ahead and do that really quick. The numerator stays the same. The 2 capital G me stays the same, which I have here in my work. But instead of re squared divided by 4, it is now 4 divided by re squared. Okay, so you got to reciprocal the denominator, which brings the 4 on top and then the re squared to the bottom. But as you can see here, now you have 2 coefficients. You have a 2 and a 4. So in my world, we're just going to go ahead and combine those 2. So 2 times 4 is 8. And then we just carry everything over. So here is 8 in the front. And then the capital G, the me, and then the re squared I haven't touched, so I'm just going to rewrite it. So in the numerator, we have gme. And then in the denominator, we have re squared. But if you recognize on the left side, when I set up the gravitational field function for Earth, the gravitational field function for Earth is just capital G m Earth divided by r Earth squared. But you notice here we have the same term, right? We have G m Earth over r Earth squared. So really, this is the acceleration due to gravity for Earth. So I'm just going to replace it with 9.8, because the acceleration due to gravity for Earth at the surface is 9.8. So my work here, I'm just going to carry it down. The 8 stays out in the front. And then this whole entire box that I highlighted is acceleration due to gravity for Earth, which is 9.8. So if you punch in your calculator, 8 times 9.8, you'll get 74.8 meters per second squared. All right, that's it for this one. All right, stay nerdy, don't be wired.